Chapter 6 More about dissolving, full easy explanation. 1. What is dissolving? Dissolving happens when a solid mixes completely with a liquid and seems to disappear. For example, when you put sugar in water and mix it, after some time you cannot see the sugar anymore. It looks like it has disappeared, but actually it is still there. The sugar spreads evenly inside the water. If you taste that water, it will taste sweet. This proves that sugar is still present even though we cannot see it. Another example is salt in water. When salt is added and mixed, it disappears and forms a salt solution. If you taste it, it will be salty. So, dissolving does not mean the solid is gone. It only means it has mixed completely and evenly in the liquid. 2. Difference between dissolving and melting. Many students get confused between dissolving and melting, but they are different. Dissolving happens when a solid mixes into a liquid. For example, sugar dissolving in water. Melting happens when a solid changes into liquid because of heat. For example, ice becomes water when heated. If you put sugar in water, it does not melt. It dissolves. But if you heat ice, it melts into water. So remember, dissolving needs a liquid, while melting needs heat. 3. Do all solids dissolve in water? No, all solids do not dissolve in water. Some substances can dissolve easily. These are called soluble substances. Examples include sugar, salt, baking soda, and copper sulfate. Other substances do not dissolve in water. These are called insoluble substances. Examples include sand, chalk powder, talc powder, iron filings, and sawdust. Flour is a special case. It does not dissolve properly. Instead, it forms a thick paste. So it is not a true solution. 4. How to know if something is dissolved? When a solid dissolves, the liquid becomes clear and you cannot see the solid anymore. For example, when sugar dissolves in water, the solution becomes clear and you cannot see sugar particles. But if something does not dissolve, you can still see its particles. The mixture may look cloudy or dirty. For example, when sand is added to water, you can clearly see the sand particles. They may settle at the bottom. 5. Separating insoluble solids. If a solid does not dissolve in water, we can easily separate it. One method is sieving. This is used when the particles are large. For example, when you make tea, you use a strainer to separate tea leaves from tea. Another method is filtration. This is used for very small particles. In filtration, a filter paper is placed in a funnel. When the mixture is poured, the liquid passes through the paper, but the solid stays behind. The solid left on the paper is called residue. The liquid collected is called filtrate. For example, muddy water can be filtered to get cleaner water. 6. Can filtration separate salt from water? No, filtration cannot separate salt from water. This is because salt dissolves completely and its particles become very small. These tiny particles pass through the filter paper along with water. So filtration only works for insoluble substances, not for dissolved ones. 7. How to separate soluble solids? To separate dissolved solids, we use evaporation. In evaporation, the solution is heated. The water turns into vapor and disappears into the air. The solid remains behind. For example, seawater contains salt. When it is kept in the sun, water slowly evaporates and salt is left behind. This is how salt is made in salt pans. This method works because water can evaporate, but salt cannot. 8. Condensation experiment. When water is heated, it changes into vapor. If this vapor touches a cool surface, it turns back into liquid water. This process is called condensation. In an experiment, when salt water is heated, only water evaporates. The salt remains behind. When the vapor condenses, the water collected is pure and not salty. This is because salt does not evaporate with water. 9. How to check pure water and salt water. You can heat both liquids. If it is pure water, nothing will be left behind after heating. If it is salt water, salt will remain after the water evaporates. This shows that pure water has no dissolved substances, but salt water does. Thus, separating sand and salt. Sometimes, a mixture has both soluble and insoluble substances, like sand and salt. First, water is added. Salt dissolves, but sand does not. Then filtration is done. Sand stays on the filter paper, and salt solution passes through. Finally, evaporation is used to get salt from the solution. So, we use more than one method to separate such mixtures. 11. Factors that affect dissolving speed. Some factors make dissolving faster, but they do not change how much dissolves. Stirring makes dissolving faster because it helps the solid mix quickly with the liquid. For example, sugar dissolves faster when you stir tea. Surface area also matters. Smaller pieces dissolve faster than larger ones. For example, powdered sugar dissolves faster than a sugar cube. Temperature is also important. Hot water dissolves substances faster than cold water. For example, sugar dissolves quickly in hot tea. 12. Important note. These factors only affect how fast something dissolves. They do not change how much can dissolve. So even if you stir or heat, the maximum amount of sugar that can dissolve stays the same. 13. Hypothesis and failure test. A hypothesis is a guess that can be tested. For example, you may say that sugar dissolves faster in hot water. This is a hypothesis. A failure test means changing only one thing at a time. If you are testing temperature, you must keep other things the same, like amount of sugar, amount of water, and stirring. This helps you get correct results. 14. Key ideas for exams. Some solids dissolve and some do not. Unsoluble substances can be separated by filtration or sieving. Soluble substances can be separated by evaporation. Dissolving is different from melting. Water evaporates, but solids remain. Speed of dissolving depends on stirring, surface area, and temperature. 15. Important questions explained. Chalk and water do not form a solution because chalk does not dissolve. Chalk can be separated from water by filtration. Pure water leaves no residue when heated, but mineral water leaves some substances behind. Seawater loses water by evaporation and leaves salt behind. Sugar dissolves faster when stirred, heated, or crushed into smaller pieces. Filtered water is not always pure because it may still contain dissolved substances. 16. Important concept, mass conservation. Mass is always conserved. This means the total mass before dissolving is equal to the total mass after dissolving. For example, if you mix sugar and water, the total mass stays the same. But volume may change. The level of water may not increase exactly as expected. 17. Daily life examples. When you make tea, sugar dissolves in water. When you wash clothes, soap dissolves in water. Salt is obtained from seawater by evaporation. Water filters remove insoluble particles from water. Final understanding. Dissolving means a solid mixes completely in a liquid and cannot be seen. Some solids dissolve and some do not. Insoluble solids can be separated by filtration, while dissolved solids can be separated by evaporation. Stirring, heat, and smaller size make dissolving faster, but they do not change the amount that dissolves. Chapter 6